Last time we developed the program for calculating the sum of an arithmetic progression, and we know that we use with the implicit none statement, that is to define all of your variables by yourself, right? So that was a good facility. So we defined the variables as the first term A, the common difference T, the number of terms n equal to 10, and we initialized the term, initialized the sum of squares, sum of the sequence, right? So that is one. And then I initialize the counter I count equal to 1. That is to signify that in summation, I have already included the first term, right? So then remaining 9 terms have been generated, must be generated, and they have to be added. And then the third step that I performed here is the after term calculation, the update of sum and the update of counter. And then I have written the I counter and the conditional statement. If I count is less than n, go to 20, which means repeat the sequence of calculation starting from the line labeled as 20. That is the specific feature of Fortran 77. So that was done last time. And just to repeat and see what we did actually was successful. So here I am. I have to get to the directory, G directory, and I know the G77 folder directly and the bin folder there. So just to be sure that I'm not using the old program, right? So I'm going to delete the old file, sum AP. So that has been deleted. And again, I check to see whether my file is there or not. So my file, sum AP, sum of arithmetic progression dot for, it is somewhere here. Okay. So sum of arithmetic progression dot for. We have to compile it. Again and again, we remind each other that that should be the compilation command G77 dot for G77 sum AP, the file name dot for, so sum AP dot exe. Okay. First time it takes a bit longer time to compile. Okay, so since no errors have been returned by the compiler, so there are no compile time errors. Run the program, sum ap.exe, and we found I count was updated to 2, 3, 4 up to 10, and the sum of arithmetic progression by this summation strategy is 155, and by formula, the mathematical relationship, it is also 155. Now let's replace the old structure with the new one. So first of all, so I'm going to erase this label. So label has been removed. So I'm going to write here do while I count is less than 10, right? So it will update the term, update the summation, update the counter. So I count was initially equal to 1. So I said do while I count is less than n, right? So the same thing we check with less than, right? So instead of this one, I will write here and do. Let me comment that one, right? So do while I count is less than or equal to n, and compute the new term, update the summation, update the counter, right? So the same structure. Just to give it a structure programming look, I add a tab, right? So it means that is the block we have repeated. This is the block that we want to repeat, right? So earlier it was labeled with 20. So the calculation within this block, they will be repeated, right? So now the point is to save the program. It is program file icon is red, which means it requires saving. So we have saved the program, and now we have to again update the program, again compile the program. I will delete the old execution file and I will compile. So it has been rightfully compiled. There are no errors. We are ready to test it. So sum AP. So here it is, right? Here it is, right? Sum of arithmetic progression 155 from formula 155. So equivalent structures, right? Fortran 90, modern Fortran. Do while structure. Do while structure is basically a conditional loop structure, right? And I said earlier, if you can write if you learn how to write one single loop, one-dimensional numerical analysis problems, numerical method problems can be solved, which are like one-dimensional numerical integration, one-dimensional differentiation, right? First order differential equations, linear or non-linear, right?